So we're given some information in the problem. It gives us the mass of sodium plus ions in 0.0250 liters of solution. So we can write that as a relationship because there's some connection between those two numbers based on the context of the problem. What we're trying to get to is equivalents per liter. Okay, so that means we need to get the grams, which is in the numerator, converted to equivalents. And we see that we have liters on the bottom, we have liters on the bottom. So we actually don't have to do any conversions for that. If we did have to, we'd still set up the problem basically the exact same way, only we'd have to do an extra step or two to convert the denominator units. So we're only going to worry about the grams for now. So we know that grams is on top, and I'm worried about getting grams to equivalents. I don't have to try to convert grams per liter to equivalents per liter. I'm just looking at converting from grams to equivalents. And so I know that no matter what, because I've got grams on top and I want to get rid of that, grams needs to go on the bottom of the next step. Now, when I have grams on the bottom and I think about, I'm talking about sodium, the only relationship I know between grams and something else with sodium is the molar mass. So 22.99 grams per mole of sodium. So now my grams cancel with grams. And again, I'm not worried about my numbers. I'm just focusing on the units for now. So if I stop my problem right here, what I'd have left are moles per liter, which is great in some cases, but that's not what we need. We need equivalents per liter. So I got to take this problem one step further. So I've got to figure out what is that connection between moles and equivalents. Now for sodium, because it has a +1 charge, okay, there's no number there, so we know that means it's a 1. That means there's going to be 1 equivalent per mole. Okay? Whatever the charge is the number of equivalents per mole. So say for calcium 2 plus or sulfur 2 minus, we would have 2 equivalents per mole. There's never a charge associated with equivalents because we're counting something. And so it's always based on the charge. So we're looking at sodium, which means we're going to use this value here. So I know I want to get moles on the bottom because this has moles on the top. I want moles on the bottom, and I put 1 equivalent. We're setting these problems up just like we did all the dimensional analysis problems back at the beginning of the semester. It's all about looking at the units. So now moles cancels with moles. And if I look here now, what units are left? I have equivalents here, and I have liters there. Whoops, I covered it by 1. I have liters there. So when I do the math, what I get is equivalents over liters. Now, if I'd been given something like milliliters here, then I could go on to another step and convert the milliliters to liters or whatever I needed to get it to. But because it was already in liters and I'm asking for liters, I don't need to go that extra step. So now we can just do the math. So now we have 3.25 grams, okay, divided by our 3.25, can't type in the calculator, divided by 0.0250, okay, and then divide that by 22.99. And what we end up with is 5.65 equivalents per liter, because those are the units that are left.